Okay. Wait, the internet is very slow now. Wow. Okay, can you hear my slide? Can you see my slide? Wait. Ugh. Is the presentation already there? Wait. My connection again. Oh. Hello? Oh, it's very slow. Okay, how about this? Can you see my present? Okay, good. Okay, let me get introduction as usual. So we'll have two speaker here from VMware, and then let me introduce myself. After that, we're gonna talk about the session. Oh. Okay, introduce. My name is Hendy Santika. Everyone usually call me Kang Hendy. I am the CEO, Chief Operating Officer of the JVM Indonesia, Kotlin Indonesia, and ID DevOps. So this is the history. So previously the JVM is called JVM User Group, was on Facebook 2010, and then it has 65K member. Then we have Facebook fan page, Telegram, Twitter, and then we moved from the Facebook group to Telegram since 2016, and then until today we have 7.2K Telegram member. So this is the event JVM Meetup. It meet up at least once a month, but in this month we have 4 meetup because the sponsor wants to get the meetup by this month. Okay. Next, I think is lagi. Wait, oh my. Oh, sorry. My slide got hang. Sorry, everyone. So I think, so we have JVM slides, but my slides got hang. And then I just want to announce that we have a t-shirt, JVM t-shirt. So if you want to order, please. This is pre-order, like I told you in previous meetup. So just please check the JVM Indonesia repo in GitHub. So then you can see the instruction how you can pre-order that t-shirt, I think. So Aris, hello Aris. Can you hear me? So I cannot stop my share. Sorry everyone. Cannot do anything. Okay.
No problem.
Aris, can you stop my sub sharing because I cannot find my pointer. Sorry everyone. I have a technical issue with my laptop maybe.
Okay, I stopped your share, no worries.
Okay.
Andy?
Okay, please.
I have already stopped your share. Andy.
Okay, thank you. So I think this is I'm gonna how to VMware from VMware Indonesia. So the one who's gonna present about the VMware welcoming from VMware is Mas Buyung. Mas Buyung is already. Are you
I'm
there?
here. I'm here.
Okay. Please.
Hello.
Okay, Mas Buyung. Okay, please do your welcoming from VMware.
Oh, okay.
So,
Sure.
Okay.
All right.
I have technical problem here. Sorry.
No problem. Should we do in Bahasa or in English?
I think it will be better in Bahasa first.
Yep.
And then about the speaker, we're gonna have in English.
Sure. Thank you, Pak Hendy dan rekan-rekan sekalian. Selamat petang menuju malam. Terima kasih sekali lagi buat kesempatan buat VMware Indonesia, VMware dari Singapura juga hadir. Terima kasih buat kesempatan untuk kita berpartisipasi di JVM Meetup hari ini. Nah, perkenalkan saya William Buyung, saya dari VMware Indonesia. Saya adalah Associate Engineer Senior Manager yang di Jakarta, bukan di luar gitu ya, sehingga saya bisa berbahasa Indonesia. Nah, hari ini saya senang sekali bisa berpartisipasi dan bisa memberikan sedikit presentasi mengenai VMware dan bagaimana VMware bisa membantu teman-teman developer atau teman-teman DevOps yang ada hari ini. Dan saya percaya bahwa mungkin teman-teman developer, DevOps mungkin awalnya bingung kenapa bisa ada VMware gitu ya di acaranya developer gitu ya. Nah, dari situlah saya mau sedikit menjelaskan relevansinya VMware dalam dunia developer dan DevOps. Nah, saya sedikit ada slide hari ini, bisa share ya. Oke, sebentar. Saya waktu. Oke. Saya share slide saya. Apakah bisa dilihat?
Yes.
Oke, baik. Jadi hari ini saya sedikit mau menjelaskan bagaimana VMware bisa coba membantu teman dari sisi DevOps Ready platform gitu ya. Seperti saya tadi bahwa VMware terkenal dengan players di infrastruktur, kita banyak bermain di sisi virtualisasi, cloud, dan segala macam gitu ya. Namun dengan berkembangnya teknologi, berkembangnya kebutuhan bisnis, kita sudah mulai merambah dunia DevOps. Makanya hari ini saya sedikit menjelaskan DevOps Ready Platform buat bagaimana bisa membantu teman-teman developer. Nah, karena sesi saya lumayan pendek, 15 minutes gitu ya, saya bisa dikontak melalui email di bawah, ada link juga saya di LinkedIn saya. Jadi jika ada pertanyaan, jika ada keraguan-raguan, jika ada mungkin mau follow up untuk bertanya lebih lanjut, silakan hubungi saya di email. Oke, saya mulai hari. Nah, jadi kita melihat bahwa developer yang ada saat ini, mempunyai fokus beberapa outcome atau tujuan dalam mengembangkan sebuah aplikasi atau services gitu ya. Ada 3 hal yang kita lihat dan mungkin rekan-rekan sekalian yang hadir hari ini punya lebih dari ini, cuman yang kita mau fokus adalah 3. Yang pertama adalah bagaimana aplikasi yang dibangun, yang dibuat, service yang dibuat, mempunyai kualitas. Kualitas di sini berbicara mengenai mungkin lebih efisien, dipakai di mana-mana gitu ya, bisa dipakai oleh banyak orang, berguna bagi banyak orang, dan segala macam. Cuman kalau kita ngomong sedikit technical, kualitas adalah berbicara tentang quality of service. Kita pastikan bahwa kualitas dari si aplikasinya itu baik, yang dimana diartikan lagi adalah bagaimana development, dan operation-nya adalah berjalan seiring. Artinya adalah mereka ngobrol, mereka sharing tentang tools, mereka juga punya integrasi yang kuat gitu ya, dan pastinya itu menghasilkan kualitas dari service yang baik, yang dimana juga mempunyai value buat end customer dari si services ataupun dari si aplikasi tersebut. Jadi pertama adalah kualitas. Hal kedua yang paling penting juga buat outcome teman-teman developer di sini adalah velocity. Microservices, container, semua hal ini adalah menuju ke kecepatan velocity. Kita mau memastikan bahwa aplikasi yang dibangun hari ini berguna dan juga diupdate terus dengan waktu yang diinginkan oleh si yang punya bisnis atau business owner gitu ya. Apalagi business requirement sekarang ini semakin berubah dengan cepat. Tahun lalu kita nggak ada namanya COVID, tahun lalu dan Januari. Tidak ada ketakutan bagaimana bisa work from home, bagaimana digitalisasi, tidak ada pendapatan ini, itu, bagaimana bisa dapat revenue tambahan. Dalam waktu sebulan, 2 bulan, bam, semua requirement berubah. Mungkin jualannya sama, cuma requirement berubah sehingga menyebabkan velocity dari perubahan aplikasi diperlukan. Nah, yang terakhir yang tak kalah penting adalah reliability, keandalan. Jika punya aplikasi yang berkualitas, yang cepat di-upgrade atau cepat untuk di-update-nya, itu nggak ada artinya kalau dia duduk di atas platform yang tidak andal, tidak reliable. Ya, dia mungkin sering down, mungkin gampang di-attack, datanya di-breach, dan segala macam. Nah, hal ini yang juga menjadi perhatian dari sebuah developer, memastikan kualitas, kecepatan, dan keandalan jadi kesatuan, dan outcome yang diinginkan oleh developer. Jadi kita pelajarin outcome dari developer ini, kita translate menjadi apa yang kita bisa bantu dari si VMware, dari sisi infrastruktur dulu. Nanti teman-teman rekan-rekan saya, Srini, dan juga Yogi akan berbicara di sisi aplikasinya. Karena saya bukan orang aplikasi, saya tidak mau berpura-pura sebagai expert di sini, saya akan berikan yang topik itu ke expertnya, yaitu Srini dan Yogi. Nah, saya akan sedikit masuk ke dalam ini. Jadi buat VMware ada mantranya kita. Kita ada 5 mantra di mana kita mendefinisikan technical requirement dari sebuah application life cycle. Itu apa? Dia perlu di-build, dia perlu di-run, dia perlu di-manage, dia perlu di-connect, dan dia perlu di-protect secara keseluruhan. Build berbicara tentang, ya sebenarnya build, membangun aplikasinya, coding, logic semua yang dibangun di sana, gitu ya. Kemudian kita run sebagai productions, di testing dulu semuanya, make sure semuanya aman, secara logiknya semua aman, jalan lancar gitu ya, secara performance juga aman gitu ya. Dan berikutnya di manage, yang arti di mana kita pastikan misalnya kita perlu taruh di public cloud supaya lebih cepat untuk berkembang ekspansinya, semuanya tervisible dengan baik. Dan pastinya juga connect dengan end user, misalnya end user-nya adalah melalui internet atau end user mungkin internal user gitu ya. Dan terakhir diprotect secara keseluruhan supaya si aplikasinya terjamin data-datanya dan tidak down gitu ya. Nah, kelima mantra ini menjadi titik poin kita melihat si application lifecycle proses yang dimana kita sudah tidak terlalu melihat di bawahnya, yaitu infrastrukturnya. VMware Cloud, mau itu private cloud di VMware, mau itu AWS, semua Azure, Google, dan cloud lainnya. Itu seamless. Karena semuanya adalah hanya sebagai infra dan dibuat sebagai as a code. Buat si aplikasi tersebut yang menjalankan build, run, manage, connect, dan protect ini. Nah, ini adalah 5 life cycle yang kita lihat. Nah, untuk menjelaskan si kelima ini, saya hari ini nggak akan buka semuanya karena waktunya atas. Saya akan fokus di build, tapi sebelum itu saya mau memperkenalkan ada 2 tim nih. Ada tim development, ada
William.
Ya, tim development dan tim operations gitu ya. Nah, di sisi development ini kita lihat bahwa bagaimana ada dua tim besar ya, yaitu developers dan juga DevOps admin. di mana developers definitely dia akan bangun programnya gitu ya, dan DevOps admin di mana menyediakan runtime sih, misalnya Kubernetes-nya, memastikan developer bisa pakai konten library yang katalog yang oke, image yang baik gitu ya, dan semuanya seamless dan gampang digunakan dan fleksibel untuk si developer. Di sebelah kanan di operations kita bicara tentang orang infrastruktur, orang SRI yang berbicara memastikan reliability dari si platformnya gitu ya, dan dua tim ini punya sudut pandang yang berbeda, tapi tetap tujuan satu supaya memastikan tadi tiga itu, the quality, the velocity, dan juga the reliability dari si aplikasi gitu ya. Nah, kita dua tim ini kita kembali ke tadi lima mantra kita. Nah, kita fokus di build. Nah, build ini kita berbicara tentang berapa hal dari si consumer atau dari si developers. Kita berbicara mengenai bagaimana saya sebagai developers ataupun DevOps admin bisa bangun aplikasi image yang sudah tersematkan security-nya, monitoring tools, mungkin agent-nya, atau semua tools yang membantu untuk si aplikasi berjalan lancar, tidak hanya secure, tapi juga secara performance di-manage dengan baik. Gitu ya. Jadi itu hal pertama yang dipikirkan oleh teman-teman developer atau DevOps dalam build, dari fase build ini. Kedua, pastinya kita mau velocity dari si perubahan si aplikasi tersebut. Kita tahu kita perlu bagaimana si developer dengan gampang bisa update environment-nya, tapi tetap memaintain, tetap bisa pakai code, nggak perlu pakai ticketing, nggak perlu minta info untuk buka ini, buka itu dengan email, tapi semuanya by a code dengan image yang tersedia dan config yang tersedia di repo. Jadi hal-hal ini yang si consumers atau si developer ini pikirkan. Nah, dari sisi providers atau si operations, mereka semua berpikirkan tentang bagaimana memberikan konten, memberikan image yang sudah tervalidasi, yang sudah tertes, sudah dites gitu ya, semuanya sudah baik, tinggal digunakan, layak dikonsumsi gitu ya. Jadi semua ini adalah yang dipikirkan oleh si pihak provider atau operations. Nah, dari dua pihak ini, dua tim ini, kita mau sedikit menjelaskan bagaimana VMware sebagai company bisa bantu dengan produk yang ada. Nah, saya sebenarnya nggak mau terlalu banyak produk gitu ya. Saya ingin menceritakan perjalanannya saja. Cuman di bawahnya ada keterangan produknya, simple aja ada nama-namanya. Cuman saya nggak mau fokus, oh ini bisa apa, ini bisa apa. Saya percaya teman-teman bisa baca di website, bisa juga di white paper. Cuma hari ini saya menceritakan filosofi di belakangnya itu. Nah, kita mulai dari pertama, bagaimana si aplikasi mulai bangun pipeline-nya untuk build, untuk publish, untuk deploy si image atau aplikasi tersebut. Ini bukan hanya tugasnya si consumer atau developer ini, tapi juga tugas si provider atau infrastruktur atau operation ini, yang dimana dia bisa membantu proses pipeline ini menjadi automated, menjadi proses yang sudah ada alurnya dan bisa dikonfigurasi dengan baik, dan juga mempunyai proses yang sudah terbaku, yang sudah tested. Nah, di sini kita bisa menggunakan sebuah produk namanya Virtualized Automation, yang dimana dengan sangat mudah automation-nya arahnya kemana, pada saat mau commit code kemana, build image di mana, publish-nya kemana, semuanya akan tersalurkan dengan baik dengan automation tersebut. Setelah itu, pasti si orang setelah kita punya image atau apps yang sudah dibangun tersebut, kita perlu capture juga berapa infra dan config. Nah, tapi kalau infra ini di-capture dengan mungkin dokumentasi pakai Word atau Excel, itu sangat memberatkan. Karena itu susah lagi untuk dibaca lagi, diartikan lagi. Mungkin orangnya lagi cuti, ganti orang gitu ya. Nah, semuanya ini kita mempermudah dengan membuat infrastructure as a code. Kita buat aplikasi si infrastructure as a code atau di repo. Mau itu dia serverless, mau dia itu ada template, ada image-nya, semua taruh di source code repo di sana. Nah, ini tetap semua automation ini kita pakai dengan Virtualized Automations. Kita pastikan semua automation ini bisa berjalan lancar dan punya workflow yang sudah terdefinisi sebelumnya. Nah, yang ketiga adalah setelah kita bangun, kita mau publish gitu ya, kita mau validasi dulu sebelum dipublish. Kita memvalidasi dari sisi performance, dari sisi security, dari sisi cost, dari sisi config, apakah semua sudah comply dengan industri yang sudah ada. Misalnya ada banking, dia memastikan beberapa checklist yang tersedia gitu ya. Nah, di sini kita again Virtual Automation menjadi tools utamanya, namun ada tools tambahan, yaitu adalah Cloud Health, di mana kita bisa lihat across public cloud AWS, Azure, Google gitu ya, perbedaan cost-nya mungkin pakai service yang ini lebih efisien dibanding yang lain gitu ya. Nah, semua ini kita bisa semakan juga dalam sebuah proses yang ada di Virtual Automation, kita bisa membandingkan dan memutuskan untuk service tersebut atau email tersebut dipublish di mana gitu ya. Dan sekali lagi validasi performance juga bisa ditaruh di sana, dan kita pastikan di build dan dirilis di tempat yang paling efektif atau efisien. Yang terakhir, yang tak kalah penting adalah memastikan image atau packages yang diberikan buat teman-teman consumer atau developer adalah image-image yang sudah valid, yang legitimate, yang sudah enterprise ready kalau bahasa lainnya. Nah, kita acquire sebuah company Vietnamese, itu adalah memberikan application catalog, kita namakan Tanzu Application Catalog, di mana dia punya image yang sudah digunakan oleh berbagai enterprise company, yang sudah dites oleh berbagai compliance atau sebagai checklistnya, dan semuanya tinggal digunakan oleh teman-teman developer maupun DevOps admin. Nah, lupa juga adalah vSphere Content Library di semua OVF dari si infrastruktur app semua di sana. Tapi itu mungkin less worry untuk teman developer. Jadi the whole journey perjalanan dari build, dari untuk code dari infranya, dari sisi testingnya, dan juga pengguna si image-nya, semua itu perjalanan ini kita bantu dengan tools-tools yang ada, Virtual Automation, Cloud Health, Tanzu Application Catalog, vSphere Content Library. Dan ini hanya, kita ngomongnya build saja. Run juga punya slide seperti ini, dan sebagai punya slide terpisah-pisah. Cuma karena waktu, saya nggak bisa semua presentasikan hari ini. Nah, saya mau tutup dengan konklusi hari ini adalah, kita punya key takeaways, ada dua tim yang berbeda, yang punya nature yang berbeda, tapi mereka harus diintegrasikan dengan satu sama lain. Yaitu adalah, kita percaya bahwa teman developers punya outcome yang tiga tadi, yaitu adalah dari sisi kualitas, dari sisi velocity, dan juga dari sisi reliability. Yang dimana kita bisa bantu teman-teman developers dengan membawa tools dari si operation sebelah kanan, yang biasanya duanya terpisah, dipakai atau di-embed atau disematkan dalam proses yang ada di teman-teman developer. Gitu ya. Jadi prosesnya teman developer dari sisi pipeline-nya, kita sematkan tools yang ada, sehingga semuanya menjadi satu irama yang baik, menghasilkan aplikasi, services yang berkualitas. Dari sisi provider juga, kita bagaimana bisa memberikan image, memberikan infrastruktur yang semua sudah dites, yang sudah dipastikan reliable, yang dipastikan sudah enterprise ready. Dan juga pastinya kita bisa membuat tools yang gampang untuk digunakan oleh teman developer, yaitu seperti Terraform dan Git. Nah, ini ada key takeaways yang saya mau ceritakan. Saya nggak banyak ngobrol soal produk VMware, karena itu seperti baca di website. Semoga teman-teman hari ini bisa mendapatkan sedikit tentang bagaimana VMware relevan dengan teman-teman developer, dan bila teman-teman ada pertanyaan berikutnya, bila ada yang pengen lebih tahu lebih lanjut, bisa hubungi saya dari wbuyung@vmware.com, atau bisa hubungi panitia. Demikian dari saya, William Buyung. Bila ada salah-salah kata, salah-salah bahasa, maafkan saya, dan semoga sukses acara hari ini, dan selamat lagi buat teman-teman JVM Meetup. Terima kasih.
Oke, terima kasih Pak William Buyung dari VMware Indonesia telah memberikan welcoming-nya, keynote-nya di JVM kita. Okay, everybody. So we're gonna have two speakers here. We're gonna have the next session. So the first session, the speaker will be presented by Srinivasa Vasu, solution engineer at VMware. Srini, he is an open source enthusiast and contributor interested in all stuff Java, Spring. He loves travel, photography, and Kubernetes. So on this JVM Meetup 45th, Srini will be presented will present about Cloud Native Spring. This session cover the native goodness of container and Kubernetes feature that are getting built in the Spring and Spring Boot ecosystem. So Srini have 30 minutes to present, and then after that we're gonna have Q&A. Okay, okay, Srini, please.
Can you guys see my screen? Thanks, Mas.
Yes, good.
Selamat malam. Good evening, all. Good to be back again. Last time I was there in person in Jakarta, DC office. I gave a talk on Spring Cloud data flow. Unfortunately, this time we have to do it virtually over Zoom. Anyways, good to meet you all virtually again. I hope everyone is staying safe, do the little that we can, like social distancing, wearing a mask to keep everyone safe. My name is Srini. I'm a solution engineer with VMware, and today's talk, the first session is on Cloud Native Spring with a K. The reason why I put K is basically, I mean, Cloud Native Spring with a C is pretty much known to everyone, right? Since the whole evolution of microservices and all those things happened, everyone is pretty much familiar with Cloud Native Spring, right? But the Cloud Native Spring with a K is mainly to go through some of the features that are being built into Spring Boot and the broader Spring ecosystem natively to help developers run Spring Boot-based application in a container form factor on Kubernetes, right? Over the past few releases, Spring team have added a lot of features natively into Spring Boot and the broader Spring framework ecosystem to support this whole Spring Boot applications in a container form factor on Kubernetes, right? This is the only slide that I have. I don't have any slides. It's more of a show and tell session complemented with some demos. I hope I will be able to get through the demos without any issues. With this, give me a second. All right. Okay. In order to run Spring Boot applications on top of Kubernetes, the first thing that we have to do is basically to create a container image, right? And as you all know, the best place to get started with the Spring Boot application is to go to start.spring.io, right? So it gives you all those dependencies. You can choose your dependencies, and then you can download the base project artifact, and then you can start building on top of it. I've already done it. I'm not going to go through it again. So this is just a normal, this is not a real world application per se. This is a normal, hello world application. It has a single endpoint. It receives the request coming at /hello, and then it's going to respond back with a string message that's being populated with a configuration class. We'll look into all those things later as we move on, but it doesn't do anything other than accepting a single endpoint and then responding back with a string response, right? In order to create a container image, right? So this is something that we have been doing it for years, right? Generally, developers always create their own Docker file. This is a very standard Docker image, right? I'm just pulling the base image from the JRE from, again, a public Docker container registry. The JRE is being pulled in from the public registry, and then I've defined a work directory. And then I've added my Uber jar, fat jar to the work directory, and then I'm just invoking that application by defining that entry point, right? This is the standard way of creating a Spring Boot application. In order to create a container image, you write this Docker file, and then you do a Docker build, which produces a container image, and then you can take that image and then deploy it on top of Kubernetes. There is nothing wrong with this approach. So let's go through the pros and cons of what are the ways that we generally follow in order to create container images to run it on top of Kubernetes, right? And then as we move on, I'll also go through what are the things that are being added natively into the Spring Boot ecosystem that simplifies this entire developer workflow. So in order to build a Docker image, it's a standard Docker build. I'm just giving a tag name boot-kubernetes, and then I'm just passing the path to the Docker file, right? So this is going to produce a container image. Give it a couple of seconds for this to get built. this is going to produce a container image, which we can take and then run our application, right? So if I do Docker run of this image, this is going to run our application, right? So this is how the container image gets created locally. And the application is up and running now. But if we look into this application, let's probably spend some time to dive into how this container image itself is composed of, right? There is a wonderful tool called Dive. It's an excellent tool to look into Dive is an excellent tool to look into the different layers of a container image. As you all know, a container image is composed of multiple layers, right? If you really want to look into how a container image is composed of, then Dive is definitely an excellent tool to look into. So I am just passing the name of the container image here. Dive pass the container image. Depending on the size of the image, it's going to take some time to extract that image to load all these things. What you get to see here is, just give a second, I probably would disable some of the things so that we'll have a better view of this image. Right. If you look at this image, the first line comes from the base layer, which we are pulling, the JRE11 slim version that we pulled in from the public repo. But those things are not important to us for the time, right? The layer which is important to us is more about the bottom one, right? So the size of the layer is 21 MB, and it consists of that application.jar file that we added to a Docker file, right? So we added this entry to a Docker file, and then that's the bottom layer in this multi-layer container. There is nothing wrong with this one, but the thing is, if you have to make a simple change to your application, again, you have to rebuild your image, and the entire jar file needs to be added to the container image. And then it needs to be pushed back to your enterprise central registry. And then wherever you're running your application, and the platform has to pull your image back again. So this is not an efficient way of building, pushing and pulling images, right? So even if it's a single line of change, if it's in few KBs or in few bytes, you have to rebuild the jar again and then publish it and then pull it back again. Though in this case, the size of the image is 21 MB, this is not a real world application, right? This is still an hello world application. But in the case of the real world application, the size would be much larger, right? It's a uber fat jar, all the dependencies, everything would be part of the jar. It's not an efficient way of, building the container image based on this approach, right? So the next, the better way of doing this is more about, instead of putting the jar as one layer in the container image, rather we can break it down into multiple parts, right? So the other alternative way is more about using a multi-stage Docker build file. So in this case, what I'm doing is I'm creating a build phase container image, which is named as builder. And then I'm adding the same Uber jar there. But instead of defining an entry point to run the jar, we are just extracting the jar in the build stage container image, right? And then in our final run container image, we are constructing this exploded file structure in the container image itself. So meaning that since the jar is already exploded, pull this layer from so-and-so named builder, and then which is under source work directory, and then copy boot.inf, which is where boot.inf lib is where our application specific dependencies are there, and then the meta.inf manifest layer, and finally the classes itself, right? And then we are constructing that exploded file structure in the container image, and then we have defined the entry point here with the main application class. This is better than the earlier approach. In this case, it's not a single layer. We'll get into dive to see how the container image itself is composed of. In this case, instead of putting it as a single Uber jar, what we have done is that we have created this exploded file structure by segregating dependencies, frequently changing layers and less frequently changing layers in its own compartments, right? So for example, if the libraries are not going to change, you don't need to push this layer back in. Obviously, your classes layer where you do your core business development, that layer is going to change frequently so that this layer gets rebuilt and then gets pushed back to the centralized registry. The downside of this approach is we are calling our own class, which has the main start main function, but the class path is defined with the wildcard pattern, right? So all the dependency jars under layer is being set as the class path, right? When you have two versions of the same jar, right, then the application is not going to behave in the expected manner, right? Depending on which version of the jar gets loaded, it's going to behave differently. You're not going to have a consistent experience here, right? So we always hit this class loading issue, right? If the jars are not loaded in the proper order, then the application behavior is going to be different, right? So let's rebuild this application again. I'm issuing the same command docker build with the Docker file, and then dive into to see how the structure is being composed of. The build is done. If I do dive boot Kubernetes again with the name of the image, in this case, this is our work directory application. And since we have defined 3 layers, application boot INF lib, all the dependent jars are in its own layer. And then we have the meta INF manifest, that's in a separate layer. And then the application classes itself in a separate layer. So previously it was 24 MB as a single layer. Now it's been broken down into 3 layers, right? The core chunk of the size is being taken by your dependent jar layers, and then you have manifest and the application classes related layer, right? So if this layer is changing frequently, right, then the amount of data needs to be transmitted between the centralized server and being pulled into your runtime platform, it's going to be very less, right? So because this layer is in the size of few KBs, only this layer needs to be built and then pushed back to your centralized registry. So this approach is better than the previous way of creating the container image. The downside of this is we have to remember the structure of this exploded file format. We should know how the jar is getting extracted and how this layer needs to be constructed. And the class path is something that we have to be taken care of, right? So if 2 versions of the same jar, different versions of the same jar exist in the class path, then the application behavior is going to be different, right? In order to improve this downside, right? So the other alternative approach is more about, in this case, the build container image remains the same. We are pulling the JDK slim from the public reference, and then we are extracting the jar here. Instead of, if you look at the entry point here, instead of calling our own main class, we are dependent on Spring Boot loader to go and find the class with main to run the application for us, right? So we are not defining the class path here. In this case, we have defined multiple layers. Again, the downside of it is you have to remember how the jar is getting extracted and how these layers need to be constructed, right? But having said that, we'll not hit the class path issue here because the jar launcher is going to set the class path and it's going to find the main class and it's going to invoke the main class for us, right? So this is better than the earlier approach. So again, if you need to look into how this image is being, how this container image is being composed of, build this image again, and then if you do a dive, you'll get to see the different layers of it, right? But end of the day, the experience will be consistent in this case compared to the earlier approach, because the class path issue is something that you don't hit with this approach, right? And with Spring Boot 2.3. So since this is something, since this is a burden so this is something that developers have to remember, right, in order to construct these layers of the jar. In Spring Boot 2.3, they have introduced a new feature called layer tools, which is more about, it creates this exploded format for us automatically, right? So and it's going to be predictable, right? So it always produces a defined structure that's not going to change. So it follows the same Spring Boot principles of convention over configuration. As long as you are okay with the conventions being brought by the framework, you can continue to use it as such. Having said that, doesn't mean that it does not allow you to customize all those things. If you're not happy with the conventions, then you can always bring your own configurations to change the behavior of it, right? In order to activate that, with 2.3, it's disabled by default. with Spring Boot 2.4, they have flipped it. It's enabled by default. I just want to show you how that feature works, right? So in this case, though I'm running Spring Boot 2.4, I'm going to explicitly disable it to show how that feature works, right? So we have to define a task, boot jar task, and then there is this method called layer, and then it has a property called enable, which is with 2.4 it's enabled by default, whereas with 2.3 it's disabled. So that's the reason, since I'm running Spring Boot 2.4, I'm forcefully disabling it, right? So if I do a Gradle build, and then if I do Java-d jar mode, so this is in order to look into the different layers that are part of your jar, so you just have to issue this command, jar mode layer tools. Once the layer tools is activated, enabled, then you'll be able to issue this command. So in this case, since I've disabled it, this is going to throw some error, unsupported jar mode, because it's been disabled in my jar. So I'll go and enable it. So once you enable this, let's rebuild our jar again. So now the jar mode is activated, right? So if I do jar help, this is going to list the commands that you can execute against it. And if I go and run list, so this is going to give me the structure. This is going to be the exact structure that you would get when you extract the jar, right? So using this feature. So in our build file, if you use Java-d jar mode, and then if you pass this extract command, then the jar is going to get exploded wherever you're running the command in this file structure, right? So this file structure is predictable. This is not going to change, right? So developers don't need to remember how it's going to get exploded. It's always going to have 4 layers, dependencies. That's where your jar files are going to be there. And then Spring Boot loader is going to carry all the Spring Boot jar launcher related classes. And if you're using any snapshot dependencies, that's going to be part of the snapshot dependencies layers. And application is where your core compiled classes would sit, right? So if I go back to my Docker file again, and then if I do bring back the last approach, so this is more or less similar to our previous approach. So in this case, the run part, if you look at the run part, since the layer tools support has been activated in this one, I'm using the layer tools to extract my jar. So which is going to produce this predefined structure, dependencies, Spring Boot loader, snapshot dependencies, and then application, right? Let's go and build our jar again. Still successfully. If I get into die, so if I go down, application layer, and then I'll disable it. Sorry. Right. So this is where boot INF live. So all the dependencies related. So this layer is being contributed by dependencies. So all the libraries are being part of this layer. And this is the bootloader layer. Spring Boot related files should be part of it. And I am not using any snapshot dependencies here. That's the reason this layer is empty. And the last layer is where our application related classes and resources will be part of, right? So now this is better than the previous approach as well, because the layers are determined. It's not going to change. So developers don't need to remember how to construct this exploded format in your runtime image per se, right? So this is going to produce the consistent result irrespective of how many times you create this container image, right? And then with 2.3, there is another approach where you don't need to write your Docker file in order to produce this container image from the source code, right? So, and Cloud Native Build Packs, it's again an open source initiative. It's been part of Cloud Native Compute Foundations, being contributed by a lot of companies, the likes of VMware, Microsoft, and Google, plus Heroku as well. So this is one of the ways to produce a runnable artifact right from the source code itself. Developers don't need to run the Docker file. With Cloud Native Build Packs, irrespective of the language runtime, when you initiate the build process, that's going to produce the container image, and it would detect the underlying language runtime, and then it brings the dependencies that are required to produce this reusable, consistent artifact for you, right? In order to enable this one, again, go back to your build file. So this is supported both with Maven as well as Gradle as well. In this case, I've already defined the tasks, boot, build image, and I'm just passing the image name here. So again, this is something that you can customize it. If you don't want to change the default opinions being provided by Spring Boot, you don't need to pass any parameters there. Otherwise, if you want to change your image name or the builder image, that's the one that does the magic, right? The builder image is where the entire intelligence lives that goes and figures out how to build this reproducible container image from the source code, right? So in order to produce this container image without even writing a Docker file, so just I'm deleting the entire content here. So if I do Gradle, instead of boot run, I have to invoke this task, boot build image. And if you look at the log here, so this is automatically using the Cloud Native Build Pack. So by default, it uses the open source Paketo build packs. Again, CNB Cloud Native Build Pack is a specification. It does not provide you any concrete implementation per se. Paketo build packs is one of the reference implementations of CNB. CNB is more about spec and the infrastructure that you need to produce this image, right? The real implementation is being provided with Paketo build packs. In a similar way, we have Google as its own builder, and then Heroku as its own builder as well. So from the source code, the builder is automatically detected. It's a Java-based application, and then it's bringing in the JRE runtime and other things that are needed to run our application, right? So the image has been built successfully. I did not write a single line of Docker file to produce this image. Rather, this image has been produced right from the source code itself. So if I go back to dive again, if I do dive by passing that image name again, all right, let me disable. Okay, this has got more layers compared to the earlier approach because these layers are being contributed by Cloud Native Build Packs. If I go down, so these are the layers that would interest us, right? So again, similar to the layered approach where it produced 4 different file system layers, right? So that's been automatically taken care of by this CNB boot build image stage itself, right? So this is our dependencies. This is where all the dependent jars go, and then the bootloader layer and the snapshot dependencies is empty, and finally our application classes related layer. This is where the application classes and the resources would get into, and rest of the layers are being contributed by Cloud Native Build Packs, right? So it produces the same image, and it's going to give you the same output as well. So if I do Docker run by passing the image name, it's going to run. My bad. It's going to run our application, and it's the same thing, right? The application is up and running in no time, right? So this is something that's been natively added into Spring Boot. The Cloud Native Build Pack based on open source Paketo reference implementation is part of Spring Boot. It's part of Spring Boot from release 2.3 onwards, if I'm not wrong, right? So And the layer tools, that's enabled by default from 2.4 onwards, so that we don't need to do anything to have that exploded structure to be part of your final runtime image, right? That's more on building the container image from the source code, the native feature that's being built into Spring Boot itself. And another next thing that I wanted to show is more on the graceful shutdown part, right? So this is something that's very common when you run your Spring Boot based applications on Kubernetes, right? As you all know, Kubernetes being a distributed system, it has to coordinate with a lot of services within its own layer itself, right? For example, if you're issuing a terminate signal to your application, then sometimes if the application, which is always the case, if your application does not get shut down gracefully, then you lose all the in-flight transactions, right? Because when you issue a terminate signal to your application layer, then the same terminate signal needs to be propagated down to other related services like service layer, ingress layer, so that your application's endpoints get removed from those layers as well. So that's going to take some time, again, depending on how much your underlying platform is loaded. It could happen in a few sub-seconds, or sometimes it would take a few seconds as well, right? So if you have any in-flight transactions, then those transactions would be lost if the application does not shut down gracefully. And again, this is a feature that's been added to Spring Boot in order to demonstrate that feature. So let's see how this works in normal scenario, right? So if the graceful shutdown is not part of your application, let's see what happens, right? So Spring Main Cloud Platform. So in order to simulate this, I'm going to pretend as if I'm running this application on a Kubernetes-based runtime, right? So in order to bring in that behavior to your application, add this property, Spring Main Cloud Platform Kubernetes, so that when you start your application, it pretends as if it's running on top of a Kubernetes runtime, right? And then I'm going to server.shutdown behavior. This is going to be immediate, right? So that would be the case most of the time. So if I start my application, just to a Gradle, or maybe let's start from here so that we can see how this behaves. Before that, let's see. I have to let's comment these lines out. Because when I issue a request to this hello endpoint, this is going to wait for the delay that I have defined. So in my application.yaml file, I've defined a delay of 5 seconds, 5,000 milliseconds in this case. So the application endpoint, this functional endpoint, is going to wait for 5 seconds to send a response back to, right? So let's stop and start our application again. Go back to my browser. If I do a localhost hello, and then go back and issue the stop command. The application is terminated abruptly, and the in-flight transaction is lost, right? So though I have issued this request even before I shut down my application, but since the application shutdown has happened immediately, the in-flight transaction is lost completely, right? So this is the challenge that you have with your application when you run it on a distributed system or runtime like Kubernetes, right? So in order to facilitate graceful shutdown with your application, so this is again a property that's been added with Spring Boot. You have to specify the server shutdown property as graceful, and then there is this lifecycle timeout per shutdown phase property. So this is something that you can set as well. Let's understand why do we need to set this property at first place, right? So typically, when you look at your deployment manifest, Kubernetes deployment manifest, there is a property in deployment manifest called termination grace period, right? So when this terminate signal gets issued to your application, this is going to get kicked in immediately, right? So this is going to wait for 30 seconds for your applications to go down gracefully. If not, then the runtime would the kubelite runtime would issue a force kill to your containers or to the containers that are part of your code, right? So that's going to kill your application abruptly, right? So this is going to get started immediately, right? So since we have defined 30 seconds here, we have to ensure that this timeout is greater than greater than the graceful timeout that you have defined as part of your application, right? So in this case, we have defined this timeout per shutdown phase as 10 seconds, or let's say, 10 seconds, because we have a wait period of 5 seconds that's been part of our application itself. So that's the reason the shutdown phase timeout is 10 seconds. And then your deployment manifest, as part of the pre-stop phase, we have to introduce a wait here. The reason why we have to introduce a wait here is because, as I explained it before, Kubernetes being a distributed system, when the terminate signal gets issued to your application, it needs to get propagated down to service and ingress layers so that the application endpoint gets removed from those layers, right? So that your container instance no longer accepts any new request, right? And this timeout period should be long enough so that the rest of the changes or the changes being broadcasted to the other systems would intercept it and then make the amendments accordingly, right? So generally the 10 seconds is good enough because mostly it would happen in sub-seconds or a few seconds. So this is something that we have to figure out what should be the ideal number to put in so that this would wait for this period to ensure that this running instance of your application no longer accepts any new connections, right? And then the graceful shutdown, whatever you have defined in your application, would kick in. So in this case, the graceful shutdown time period is 10 seconds, meaning that your application would wait for 10 seconds for all of your in-flight transactions to get processed successfully, right? So again, it depends on your application's behavior. If the transactions process in few seconds, less than 10 seconds, then 10 seconds, whatever we have defined here is good enough. But if you have any long-running transactions that's going to take more time to get processed, then you have to change this number accordingly, right? So again, the terminate graceful time period is the maximum period that it would wait before it issues a kill signal to your application. And the stop period, pre-stop timeout should be long enough so that the change gets propagated to all the distributed services within Kubernetes. And then this would wait for 10 seconds for the in-flight transactions to get processed successfully, right? So in order to simulate this change locally, let's run our application again. Let's run our application again, and then I'll delete the logs because if I go back to the same endpoint again, come back and issue a stop command. If you see here, this time, you get to see a new message in the log, right? So since we have passed this property to our application, Spring Boot is going to initiate a graceful shutdown, meaning in this case, it's going to wait for 10 seconds for all the in-flight transactions to get completed successfully before it shuts down itself, the running instance itself, right? So in this case, I've got the response back. The same behavior as what I did earlier. So last time the transaction got killed abruptly, but in this case, it waited for the in-flight transaction to get completed successfully before it shuts down itself, right? So this would be pretty useful when you run Spring Boot application on a distributed platform like Kubernetes, where so many other services are involved, where a change would get where a change would take relatively few seconds to get propagated to all the dependent services. And also a new property. So this is added as part of Spring Boot 2.2 or 2.3. I'm not sure about the release. So if you go back to actuator endpoints, so let's stop my application. Let's bring it up again. We go back to my actuator endpoint. So Spring Boot has added this new probe state called liveness and readiness. So this would be something that's very helpful, right? So these are all some of the recommended practices that you have to follow if you're deploying your application on Kubernetes, right? So readiness probe is more about to see whether your application is ready to accept traffic, and liveness probe is more about checking the health of your application, whether it's responding to your request or not, right? So previously, generally, before these things, the health check endpoint would always give you the services that your application is dependent on. But with this endpoint, this actually gives you the health state of the application itself, right? So whether your application is healthy or not, right? So along with that, this is something that you can customize as well. So if you want to define your own liveness and readiness probe state based on a different logic, you can customize that part as well. So application change event is something that's been added. So you can have that application change event as part of your application to change that behavior, right? And the final thing that I wanted to show you is, I'll wrap it up in five minutes max. The final thing that I wanted to show you is the support that's been added to Spring Boot from externalizing your application configuration properties, right? So generally we keep it as part of your application YAML or properties file, and sometimes depending on the environment that you run, then you create multiple profiles. Then you'll have application -dev, -prod, -preprod, and all those files will be there. And then you can externalize your properties as well, right? So if you're not running on a platform like Kubernetes, then you rely on Spring Cloud config to externalize your application config file. But on a runtime like Kubernetes, it comes with its own externalization as well. So you can keep your application configuration in config map and secrets, right? So if you have any services-specific credentials, then you can keep them as part of secrets object, or your application-specific non-sensitive properties can be kept as part of config map object, right? So let's see how Spring Boot natively supports that externalization part, right? So in this case, I'm going to run my application on a real Kubernetes platform to see, because just to show you how the file structure is being composed of there, right? So this application it's the same application. I'm running it on VS Code GitHub code spaces. If you look at here, so this is a new property that's been introduced with Spring Boot 2.4, where you can import your external configuration properties, whether it's coming from a key value structure or whether you have kept it as part of an external file in config maps or secrets, then you can load it from your application.yaml file, right? So, you can load it from the class path. So if you have kept multiple files as part of the application itself, then you can pass class path, you can prefix it class path, and then you can load multiple files. Or if you have kept it as a file, defined as a file in a config map, then you can, using this prefix file, then you can load that external config map file. Or if it's a key value pair defined in your config map, then you can use config tree to load that file, right? So when you have defined it, when you have defined in the form of key value pair in your config map, so generally what happens is your key becomes your file name and the value would be the content of your file, right? So if you go back to my Kubernetes resources here, under config map, I've defined both the forms here. The started@hello is more of a key value pair. Started@hello is the key, and hello there from config tree structure is the value there, right? So when you look into your running container, when you do a kubectl exec into your running container, then this would be a file. This started@hello would be a file name, and this would be the content of your file. Whereas in this case, the app.yaml would be a file itself, and whatever the properties that you have defined within the YAML file, that will be the content of your app.yaml file, right? So in this case, this is the way that you have to load both the properties. Since we have defined the same properties in both the cases here, because started@hello, right? And depending on how we have defined the structure, the one that's been, so in this case, I've defined my file loader first, file import first, followed by config tree. So since the config tree is defined later, so whatever the value that you pass as part of the config tree, that's going to override the keys with the same name, right? So in this case, if I run this application, the output is going to give me hello there from config tree structure, right? So in order to run this application, let's do a scaffold. I'm again using an open source tool, scaffold run. All the scaffold related artifacts are predefined here. Scaffold run into this namespace in the Kubernetes runtime that's running in this environment, and then push it to this repo, whatever you build. Push it to this repo, to this registry, followed by the user, and then launch my application in another tab. So when I run this one, the scaffold is going to, again, scaffold in turn uses cloud native build packs, which is something that I defined as part of the scaffold configuration itself. In this case, it's using cloud native build packs to produce this container image from the source code. So scaffold is running our application. And since I haven't done any change to our application, it's going to use the image or previously built image itself, right? So the previously run image is being cached locally. Since there is no change compared to the working file structure against the previously built image, it's going to reuse that same image to deploy our application. And again, all the deployment manifest, config map, everything is defined. So Scaffold is going to use customized to deploy our application. So these are all standard open source tools to deploy application or to deploy these Kubernetes specific manifests onto the runtime, right? So it's deploying an application, give it a couple of seconds, few seconds. It's going to prompt me with port forward. That's going to open our application in a new tab. So open a new browser. So if I hit this endpoint here, so this is again running on a Kubernetes cluster. So if I go back to differential here, I can do cube get namespaces. So these are the different namespaces that are part of this Kubernetes cluster. And if I do hello endpoint, this is coming from hello there from config tree structure, right? So this is the way that we can exercise our application-specific configuration files, leveraging the native capabilities of Kubernetes in the forms of config maps and secrets, right? So these are the things that I wanted to show you guys. I hope this is useful. Thank you again. Terima kasih.
Okay, thank you, Srini. We have a few questions here. Some of the question.
Yeah.
Okay, this is from Rido. Is it approach have possibility security issue? Cause it expose layer of app when someone dive to the Docker image. In your opinion, which best approach in Docker file based on image size, initial time to start, etc.? Thanks. That's the first question.
Yeah, so the reason why I use dive is to show you guys how you can understand the content of this layer image, right? So generally, you wouldn't use dive as part of your developer workflow, right? So the reason why I used it is to show you how the layer is being composed of, right? So when I initially built my application container image, it was a Uber jar. The size was 20 MB or so, right? In a real world application, the size would be 100 MB, right? Whereas in the last approach, we leveraged cloud native build packs to produce the container image. In that case, the jar itself was got exploded in 4 different layers, where the application was frequently changing layer itself was is in its own isolated space, right? So that's how it's going to get created and going to get pushed to the container image. And the good thing with cloud native build packs approaches, the container image is being produced by the underlying reference implementation itself, right? So it's again being a lot of companies are involved in this. The core objective of that initiative is to get rid of, make sure that we have less security related issues being part of the final image that we produce, right? So when we write our own Docker file, generally we bring all those layers from public sources. Sometimes we don't verify whether those are all authentic sources or not, right? So in this case, when you leverage cloud native build packs, all these layers are being contributed by the reference implementation, right? So if you have an enterprise supported version of one of the reference implementations of CNB, then that vendor is or that company is going to be responsible for all these different layers. That includes your container file system base and all your runtime related layers, right? So which includes the JRE runtime and rest of the other things that are being part of the image itself. And it's a responsibility of the vendor to ensure that whatever they release as a part of the product, it's completely tested, free of most of the critical and high vulnerabilities. But none of the vendors wouldn't always be able to ensure that it's completely free of vulnerabilities, right? You would still have certain low or medium CVs being part of it, but those CVs won't be very serious in order to run your application in production, right? So that's the reason leveraging CNB to build your container image is the most efficient way. And it ensures that whatever the image that gets produced, it's free of all this security related challenges.
Okay, I think the second question is from Ade Aris. Can I configure in decentralized server in Spring Cloud Native?
Yeah, Spring Cloud Native. It's a nice segue to the next session. Yogi is going to talk about Spring Cloud Native.
I think.
native is another way of reducing this native image for the underlying runtime, right? The challenge there is the build process is going to be longer. You have to wait for longer time to produce that native image. And the boot time is going to be, it's going to be in sub-seconds, and it's going to have less memory footprint, but at the cost of longer build process and then less runtime optimizations per se, because in your final image, you're not going to have your JRE runtime. So generally, the hotspot would do a lot of runtime optimization. That's something that you won't get to see in a native image, but it's going to have a better boot time as well as less memory footprint as well.
Okay, I think it's enough for this session. I think everyone you can ask to the speaker after the second session. Okay, thank you, Srini.
Thank you, Mas.
Okay. Okay, the next speaker is Yogi Rampuria, advisory platform architect for VMware. Yogi is as an advisory architect, works closely with customer engineer, architect, and leaders, helping them create the ideal environment to build, run, and manage modern cloud-native apps from the data center to the cloud to the edge by leveraging best-in-class app modernization technologies and practices. So in this JVM Meetup, Yogi will present about Spring Native. This session covered the Graal VM native integration with Spring Boot and the best way to get started experimenting with this next wave of cloud native feature, because this is a new feature from Spring Boot that already released, I think last week, yeah. So Yogi will explain about Spring Native deeply. Okay, I think Yogi, please.
Thank you so much. Terima kasih. Selamat malam. And that is the limit of my bahasa. So I'm going to English now. Thank you very much for actually inviting me for this one. I wanted to actually take the opportunity to share some of the updates that have come in through the Spring Native project, and also show you some of the benefits that it has created. And it is very nicely in continuance to what Srini has just shared. So what he shared with you is how you can make it very, very easy to take your Spring Boot application and run it on a cloud native environment like Kubernetes, right? And he has shown you various tools that you can leverage on that. Now, once you start getting into that sort of a framework, you will start realizing that your boot times on the Spring application may not give you the most optimal results, right? You may want to reduce the boot time, and that's where you may actually do some optimizations on your end. So, but as the project sort of steward for Spring team has actually tried to solve this through the use of this new technology called Graal VM. So I'm going to take some time in going through the Graal VM, very simple examples, just to give you what Graal VM can actually provide you, and then how it works with Spring, the Spring Native project. All right. So I will just make sure that where's my presenter? That's it. All right. So my name is Yogi. I am an advisory platform architect. Andy has already introduced me, so I'm going to skip to the main event. So Spring Native has gone beta on March 11th, which is like just last week. So it had been in alpha since last year. It came out last year, August, I believe, as an alpha. Now, being in beta, what does it mean? It means that you can now actually get enterprise support for this. So in his presentation, in the earlier presentation, it was mentioned how we are actually helping large enterprises with the support for the open source. Spring Native is now part of the ecosystem. So if you start using Spring Native today, rest assured, like you are not using something that is unsupported, or you only have GitHub issues to solve your problems. We can solve it for you. So the agenda is going to be like, I'm not going to go through all these things because typically this presentation is about 2 hours long. I'm going to go through the Graal VM aspects and the Spring Native aspects and some of the comparisons on some of the results that we have gotten. Okay. So first of all, Graal VM, the secret superpower is behind the Spring Native. Graal VM has been a project in open source for a few years now. There have been quite a few projects that have been influenced by it. Many frameworks, it's been used, embedded in a lot of even enterprise class products. So what it gives you is, first of all, it gives you the ability to actually have polyglot runtimes. So in your code, you are able to actually access libraries, frameworks, code, SDKs, which are present in other languages like say JavaScript, Ruby, Python, C++, even WebAssembly, right? Bring it all together. You can run it through the Graal VM. And then the Graal VM itself is now being used in a number of products. So for example, in Oracle database, they actually use Graal VM. But the most important thing is native. And that is where the Spring Native is actually taking the advantage of Graal VM. Now, what does Graal VM native image technology comprise of? You take your Java code, you have your JDK, you basically do the Graal VM runs a static code analysis on this thing and does ahead of time compilation and creates your entire sort of binary ahead of time. So your compile code and the heap and initial heap and everything is built into your binary ahead of time when you build it out into a native image. Now, what are the benefits of doing something like this, right? So first of all, straight off the bat, what you will find is your memory footprint is lesser. It's reduced 3 to 5 times, right? So now, if you put it at scale, if you're running, say, as Srini showed, containers, right? If you're running hundreds of containers, that kind of a change is an order of magnitude different from what you get otherwise. And the other portion of it is those faster startup times. When you're running containers or serverless kind of workloads, this is very, very critical because you actually run containers very, very quickly, and containers are expected to be more ephemeral in nature. So for example, your containers may come up and go away in a span of 10 seconds. If your startup time is 5 seconds, obviously that is like almost 50% tax on starting the container. But if your startup time is sub-second, and if you're running more and more of these containers, you get a very good optimized environment, right? So this makes it a very, very good fit for containers as well as the serverless environment. Even the efforts in the community at large, like Knative, this will make Spring a much more viable choice in that ecosystem. Now, there are trade-offs, okay? And this is a very, very important slide. You have to remember that when you run everything on JVM, you have quite a few things which are working in your favor. It's a highly matured ecosystem. Your latency and throughput is fairly good, and your builds are great, right? But where it actually has issues is memory footprint and startup times. And that is where something like Graal VM or native images on Graal VM actually outshines by a long shot. Your startup times are going to be very, very low. We'll see in some of the examples that I'm going to share today. And your memory footprint would look really, really small compared to other things. Latency and throughputs, still as the Graal VM ecosystem kind of matures, the engineering and community sort of comes together to solve problems. you have to understand that hotspot is like almost a decade of engineering, whereas GraalVM is not as much, right? It's pure, it's about a couple of years of engineering. So the key difference that you always should remember when it comes to your native images, out of all these things, the most important one that you should remember is your configuration has to be done upfront. So if you're using any reflection, any resources, any proxies, you have to actually create it into the configuration files for the native images. GraalVM actually has a very nice documentation stating how do you actually specify these reflections. We'll see some samples of that. The other one, which is sort of counterintuitive for all of us, for the Java developers, is the class path. The class path is fixed at build time. It's not at runtime. So you have to be very careful about that. The lazy class loading is obviously not there because everything is compiled into a static binary. So there is no more loading things from outside. It's all baked in. And there would be some code that would be run at compile time or build time because the compiler has to decide what needs to be proxied, what needs to be replaced, or what needs to be inlined, right? So GraalVM native is the biggest inspiration behind the whole Spring Native project. But apart from that, there are many projects that you will hear about in the ecosystem, in the JVM ecosystem, like the project Laden. But always remember, as of now, it's more of an early adopter kind of a thing. So directly going and using GraalVM may not be in your best interest, but what we are trying to do is we are trying to make it easy for you to adopt it through the Spring Native project, right? Now, let us just look at a couple of samples of how GraalVM actually works and how easy it is to actually work with the whole GraalVM ecosystem. So the code, the samples that I'm using, they're all actually parked at the native Spring workshop. I think I have to change the URL. I'll change that later before sending out the slides. This is the repository where I have kept all the sample code. So let me just switch over to my browser, my source code. So we'll look at a very simple example of we'll look at a very simple example. This is a simple code which is doing nothing but calculating the capitals in a sentence, right? And it goes through a series of iterations, and you know why we are doing that. We are just doing that to increase the CPU utilization and nothing else. Very simple code, right? Now, let me just go back. Now, first example, if I go to this, I have actually provided the instructions of if you were to run this on your machine, what is it that you're going to require? So, one thing is if you're using a Mac, the native image creation doesn't work on Mac yet. So you will just have to use either a Docker container or you just use a Linux-based VM. The instructions for both are actually just here, right? You'll have to install GraalVM. So the instructions for installing GraalVM are over here. You can just go to the build, the releases section, download it and install it as per your own environment. I have also put a link to the actual GraalVM installation instructions. Just set the Java home path variables, your regular things, right? Now, let's go to the first example. Let's just, we saw this example, right? It's a very simple sort of an example. All it does is does a lot of iterations on the sentence, right? I'm just going to compile it. Now, one thing is I am using GraalVM based version of the JDK runtime, right? So whenever I'm actually compiling, it is internally using the GraalVM to compile the code and optimize it, right? If I just run this code that I have compiled just now, if I see out, you can see that the file is outputted here. And if I run it, the iterations run. And because I'm running it on GraalVM, the native compilation, what it does is that it runs those many iterations in about this many seconds. Now, if I want to see that I don't use the GraalVM's ahead of time compilation or method inlining and all those aspects, and I want to turn it off and just see what the non ahead of time performance would look like, I can actually do that using this very simple instruction. So what this is doing is that it ran for, it turned off the CI compiler, and it actually ran same amount of instructions, but took longer, right? Now, but this so far is doing everything in a JVM setting. Now I want to actually make a native binary out of this same piece of code. So this is how I'm going to do it. I hope it's visible to everybody. This is the command native image, so -- static class path out, and what is my entry point and where I need to compile the file to. And if I run this, it takes a couple of seconds, as Srini mentioned. Just give me 1 second. This is a demo fail. Somehow I don't have. While that is actually getting installed, let's just look at one more example before we can go back to the native binary. This is a second piece of code, which is it's basically blending points, right? So it is doing more iterations and more deeper analysis on the pixels, right? It uses the point class and blends the color on those points and runs a lot of loops, 1, 2, 3, about 3 level deep of loops. So if we simply compile this and run this using the GraalVM's compiler, this is what we get. Each sort of iteration is taking about this long. Now, if I were to turn off the ahead of time compilation capability of the JVM and just run it without the AOT, I would actually see much longer iterations, because the method inlining or method replacements, they are not kicking in, right? So you will actually see everything running for much longer period of time. And let's see how we are doing on that GCC part. Okay, it's done. So now if I'm going back to my earlier example where I want to actually build out the native image for my code. So I needed the GCC library to compile it into a native code. So this is what it is doing. And as Srini mentioned that through this, your build times are going to be longer, but your runtime, your startup times are going to be much faster. So we will see the effect of that. It's going to fail on me. It's okay. I have another example which actually compiles. I'll come to that one. We will see a native binary being built there. So Okay, so I just have a simple make file. What it does is that it does a Docker build. As I told you, this is on my Mac, so I cannot actually create a native binary on the Mac using the GraalVM as of now. So what I need to do is I need to actually do it in a container. So this is a simple Docker file that I have created, which basically does the multi-stage build that Srini had mentioned. So what it does is that it basically compiles the Java file, runs the native image instruction that I was trying to run earlier, but I couldn't. And then what it does is that it just times the JVM based run, and it also times the native run. Okay, so when we build this, we will actually see the difference in the timing of running the simple instruction. It's not a whole lot because it's just one hello world program. So if I say hello world here, very simple program, nothing too dramatic about it, right? And but the most important part is here. So Srini actually showed a very nice way of generating container images. Here, what I'm actually trying to do is I'm trying to create an image without any extra libraries, right? Just a simple scratch, which is basically an empty image, and adding only my compiled application. Not even a JVM, not even a GraalVM, none of that. Just my own binary and creating the entry point, asking for that particular application to be run. So let me try and run this, okay? So I have basically written a make file to do this. So if I do a make demo, it will basically execute that. So first thing, it basically does a compilation on this. So it executes the build. Now my Docker file is a multi-stage Docker file. So my Docker file is a multi-stage Docker file. So what it does is it first goes and picks up the GraalVM from the GitHub repository of GraalVM. And after that, as we saw earlier, it will run the Javac to compile, then the native image instruction. So yeah, the GraalVM itself is a decent chunk. Now, here's the fun bit. When we run this, as I told you that creating or building the image itself or building the binary itself takes longer time. So that's what we are seeing right now. It's actually building the whole thing, and it's basically incorporating all the instructions that are required. Actually, it's just one line of code, right? But it still has to analyze everything. Now, this is the interesting bit. This was my JVM based run. Real world time was about 127 milliseconds, whereas the native was 1 millisecond. Huge difference, right? This is what native images can actually do for you. Now, as I told you, when you do this, you have to actually specify your reflection. So if you're loading any files, if you're loading any classes using reflections, all those things have to be actually specified as part of your build. Now, if you use Spring Framework, you know that there is a lot of reflection that is used, right? So in order for the Spring Framework to be able to actually support this model where you don't have to go and dig into every library that you're using under Spring. Every library of Spring is basically coming up with the proxy, the reflection information, all those things packaged into them. So when you create, when you add Spring Native as a dependency in your project, all those things are automatically taken care of. We will see a demo of that in a bit. So what does it take for you to actually do this, right? There are a lot of sample projects which are in this particular repository. The link is also there on the workshop repository. What you need to do is essentially go to Spring Initializer, and let's actually go to the Spring Initializer. And then you basically create a Spring project. So as Srini had shown, start.spring.io. I'm just using a shortcut to pre-populate everything. So here you add Spring Native as a dependency in your project, right? So what this will do is everything that is needed for the GraalVM based compilation is taken care by this particular project. And I hope you have used the Explore feature on this. So if you go to the help, this is the new sort of a UI, right? It's been there for at least a year now, where it actually shows what kind of projects you're using, what kind of additional links that are there. This is generated automatically for you. Now, let's say you add a dependency which is not actually supported, right? Not yet supported, because there are a lot of Spring projects, like for example, Spring sessions, right? So if I go to this Explore again, and if I go to the README, help file, it actually tells me that this particular dependency is not yet, it doesn't work with Spring Native. So if you're going to use a certain dependency, look for this for that dependency, right? So whenever you try and create or experiment with this, yeah. So I already have this project generated, so I'm not going to go into that, but Spring Native, simple project. If I look at the Spring Native project here, go to source control, main, Java, Spring application. Looks like a regular Spring Boot application, no difference, right? Application properties is there. Now, where is the difference? The difference is if you go to the form.xml, you will start seeing, first thing, you have in the plugins, you have configuration for the Paketo builder, which is going to basically create the images. You saw Srini use that in his project earlier. Then this plugin, the ahead of time compilation plugin, is also activated in this build. And yeah, this dependency on Spring Native is basically part of this. Now, with this simple change, I have the project downloaded here. I simply run mdnw spring boot build. What it will do is it will go through the whole cycle of compiling all your Java files, running the test cases, and then invoking the build image. But this build image is going to actually contain the native binary. So we will use the same dive tool to examine the layers of the image that comes out of this. So by default, the image name that is actually built by this is using that name. So we'll wait for this compilation to actually finish. Again, under the hood, it ends up using the same GraalVM based on the Java version that we specify. So here, our Java version is 11. So GraalVM comes with support for Java 8 and Java 11 as of now. So when you try to download the GraalVM, you will find those two versions available, right? While that gets built, let's actually jump to an alternate example. So one of the most used examples in most of the Spring demos, right, is pet clinic, right? And when you have a pet clinic, you typically have MySQL database or something of sorts, right? So again, same story here. This is pet clinic JPA application compiled into a native image and running against a MySQL database. So I think I already ran this. I think I'm over time, but I will just show this thing before I. Okay, so I have a Docker Compose file, which basically runs a MySQL server here for me. And then the pet clinic application is run using this particular image, right? Where does this image come from? It actually gets built here locally when we run the same Maven build command, right? The command to build this is also present in this directory. You can simply run it. It will take care of building the application for you, right? Now, just to verify that my application is up and running, yes, it is up and running. And if I go to that's my server. Yeah, the application is up and running. Now let us actually examine this particular image. Okay, so earlier the tool that Srini had used, so same dive tool, we use that. Okay. Now over here, when I start looking at it, I have layers, other layers, but this is the layer that I am most interested in because this is going to have my actual application. And this is the, what is interesting, there's no .jar. This is your actual application compiled into a native binary packaged into the Docker image. And if you look at the sample code, there is no difference in the sample code. Automatically, because we add the Spring Native dependency into the project, it takes care of making sure that any driver loads or anything are taken. So that I just want to go back to the earlier. Yeah, it's built. So if I dive into this, our own sample, dive into this particular. Again, you'll find the same exact thing, which is we saw in case of pet clinic, same thing over here. Our application is actually compiled into a native binary and added into this project. So when we run this application, we can actually run this very easily. So let's say Docker run. You see the overall startup time of this application is like barely anything. It's like 23 milliseconds or something. Yeah, so it gives you faster startup time. The only caveat is your compilation time is going to be longer. So with Spring, you actually get the best of both worlds. When you're doing development on your machine, you can actually leverage the JVM based compilation for your testing and everything. But when you actually build it for production or deployment on a server, you can actually use the native binary to speed up the startup time. So with that, I'm just going to, as I promised, we have some comparisons that I would like to show you. This deck is going to be available on the workshop page, so you can also see this. But this is something that I wanted to share. These are some of the numbers that have been run. So over here, for the build time, if you see, it takes about 8 seconds if you're using just plain vanilla JDK. But if you use the native application, your build time is much longer. But your memory at runtime is dramatically reduced, right? And startup times is like unthinkable, right? Same thing with the pet clinic JDBC application that I just showed. This is the kind of build time and in native application. Again, huge increase in build time, we know that, but memory is about 75% lesser and startup times 94% lesser. So this gives you a very good idea. We have a couple of other examples also. All these examples are there in the Spring Native sample repository. You can run them yourself to try it out. Before I close, I just wanted to highlight which all projects have, which all starter projects have already gotten support for Spring Native. So we have support in all these projects. So if you look at your regular JDBC, Mail, Timeleaf, RSocket, in terms of the data source driver kind of combination, you have MySQL, Postgres, H2, gRPC, Spring Kafka. If you're using web, Spring Web, it's supported. So you can actually leverage native. You can actually build applications to native binaries and use it with Spring Native. And yeah, so we are going to have a bug fix release 091 soon, which will have bug fixes and support for 244. That's all from me at this point. Thank you.
Okay, thank you, Yogi. We have a few questions for you. Some of question already answered, but maybe you can add it. First question is Anuk Swamun. The question is, I can see that the solution have a high dependency to the GraalVM. How do you see Oracle commitment to it?
So GraalVM is a open source project, and we are actually investing in engineering on that front as well. So I think the community is getting bigger and bigger. So it's, I mean, even if there is, if let's say potentially there is some sort of commercial aspect to it, I think the community is still quite strong to actually take this project forward.
Okay. Do you see this Spring Native compilation solution as a production-ready solution or still in preview?
Yeah.
Do you have any timeline to support the stable version release?
I think, I mean, part of it I answered in my last slide when I showed all the projects which are available for the projects which are already supported, right? And you will see that the most common ones are actually part of it. So, I mean, you can actually certainly use it for production.
Okay, I think the next question already answered.
Yeah, I already answered the memory consumption part, right?
Does every Spring feature, which means Spring Cloud, Webflow, that is compilable to native?
Correct. So I think the last slide that I showed, it actually, and the slide is going to be there in the workshop Git. So you can actually look at the full list there.
Okay, what's next? How far we can use your third-party library?
You can use the third-party library. So because GraalVM actually provides you with the capability of providing your reflection information and things like those. So if the third-party library comes with support for something of that type, then you can directly use it. If let's say there is a library and it's somehow breaking because of some reflection aspects, then you can actually build those out in a JSON file and provide it to the GraalVM. But that is the work that you will have to do.
Okay, will you share the slide? Oh, I think the slide will be shared after this to me first, and then I will spread it out in the group. Okay. So of course, maybe everyone here in JVM Meetup wants to see the code. Okay, never mind. I will ask Yogi and Srini to have that slide and code.
There in
Sure.
the repo. Yeah.
Okay, everyone. Do you have any another question? You can write it, type it on the chat room, or you can open your mic on mute. Okay.
Okay. Thank you, folks.
Okay. If you once again, do you have any other question to ask about this? So, right. So while waiting for your another question, I think I will share the link about the feedback. Okay, JVM as usual. So please here. That's the link. Oh, let me type again. Nah. Okay, while waiting you for your another question. Oh, another question is from Aji. How is the deployment approach for AWS Lambda?
Very good question. So AWS Lambda has recently has support for containers now, right? So you can use containers for that. And the other one is, yeah, so because you can use containers, so I mean, this actually builds down to a container, so you should be able to just use it.
Can we use custom runtime to run it natively?
What do you mean by custom runtime, please?
Yeah. Aji, can you explain what do you mean with a custom runtime? AWS Lambda runtime, it means.
So in case of because typically with AWS Lambda, you would obviously have a runtime, but if you have a container, then it shouldn't matter, right?
Yes, I think yeah. Okay, is there any other question? And then please don't forget to give us the feedback for this JVM meetup tonight. So if there's no other question, so I think Pavilion, is there any more anything to say from you from VMware?
No, Pak Hendy, thank you so much. All good. Thanks for the opportunity for having us.
Okay, maybe Yogi and Srini want to say something before we close this JVM meetup tonight.
Thank you for inviting us, Pak Hendy. Everyone, please stay safe. Thank you.
Terima kasih for inviting me.
Okay, before we close our session, please turn on your video and then let's take a photo together as usual. Umam, please share. Okay. Okay, everyone, please turn on your video so we can take our your photo together. Okay. Pak Aji, Resi Dwi Tawasa. Oke.
Satu slide doang ya, Kang ya?
Yes. Ya, satu aja, nggak apa-apa. Ari Dwi Prayogo, Resi. Oke, I think nggak ada. Oke, langsung aja. Mana Aris?
Halo.
Okay, good. So we have already the winner for this JVM meetup. First is Rido, kemudian next Aris, Umam, Aji, and Imhotep Anukswamun. So please PM me after this, after this JVM meetup. So I will wait. I'll put again in chat room. Thanks for your question. Get ready to take photo, okay? Umam?
Oke. Ayo, 1, 2, 3.
Dan okay, another style, freestyle. Go. One last shot. Okay. 1, 2.
Hitung, Kak.
Okay. 1, 2, 3. Okay, thank you everyone. Thank you VMware. Thank you Yogi, and thank you Srini for our sponsorship and our speaker. Let's see for another JVM meetup, next JVM meetup. So okay, thank you everyone. Thank you for terima kasih semuanya ya. Jangan lupa
Terima
3M,
kasih,
3M,
sehat-sehat
3M.
semuanya.
Stay healthy, and then stay away from the COVID-19.
Amin, amin. Selamat malam
Oke.
semuanya.